So the first thing we're going to do is to evaluate the integral by hand. Then we're going to check using our calculator. But the way that I have this is most of the times, anytime you have a polynomial that looks kind of crazy, even if there's a square root mixed in, try to see if algebra, simplifying it, can make it any easier on you. So what we got here is I'm going to take each one of these. I'm going to divide each piece by its own r squared. Now you could do that in your head and write it out, or this is officially what we're doing. This is the part I would do in my head. And I would say, you know what? If we have an r squared on top and on bottom, that's going to reduce out, and I'm left with just 5. And then if I have an r on top and an r squared on bottom, I'm left with 1 over r dr. So that's the first step, is you just have to do a little bit of simplification. Now we have two very quick antiderivatives. So remember, we're thinking whose derivative gives me 5? Well, that would be 5r. And then this one's big. So one of the things I just noticed, and I want everybody to really pay attention to this, this is 1 over, you can think of it as 1 over x if you want, but the antiderivative of 1 over x is the natural log. And one of the things that I noticed on the first quiz we took was a lot of people were just forgetting the absolute value bars around the x. You actually do need those absolute value bars in there. So please make sure that that is there. And then what do we have to do? We have to evaluate it at e and at 1. So we're going to take the upper limit first, plug that in. And actually, this should be an r right here, not an x. That should be an r. Let me redo that. I don't like that. That'll be the natural log of the absolute value of r. Okay, so then we're going to plug in e into the first spot. Notice how e went into both pieces. And then we're going to subtract, and the parentheses are key here. One of the things we want to really focus on as we get closer to the AP test is, are you practicing proper notation? And one of the things that a lot of students forget is if you don't put these brackets here, it looks like you're only subtracting the first part and not the natural log of 1. All right, so then we're just going to simplify 5 times e plus the natural log of e. Technically, the ln and the e reduce out, and we're left with this exponent of 1. And then this is minus 5 plus the natural log of 1 is 0. So then I end up with 5e plus 1 minus 5, or 5e minus 4. Now, if this was, most likely this would be a multiple choice question on an AP test. So you wouldn't technically have to show all this work, but I recommend it so you don't make any mistakes. But you would have to be able to get to this answer. Now, we did show you how to do this on your calculator, and we're going to go over that right now, just so you guys have a quick review of what that looks like. So what I'm going to do is I have an option. I can plug in the original problem, or I can plug in any of its algebra equivalent expressions. But to do this, and again, you should have watched the video last week, Wednesday. It showed you how to do this, but you hit the math button. And then you go down to option 9, and that's the finite integral. Okay? Once you do that, you hit enter. Now here's the thing that may differ. If you have a calculator at home, it might not be in this mode. It might be in a different setup. It might not have the integral symbol. And the video goes through and tells you how to set that up. So hopefully you're going to go through and watch that again if you didn't get it. Otherwise, you're going to stop in and see me during my office hours. And then we're going to go from 1 to e. Now e is a little unique because if I put e here, it forces me to put an exponent. And since there isn't one, there's always a 1 in that exponent. And if I plug in the original value here, so if I go to the original spot, I have to put parentheses around this numerator. So I'm going to put an extra set of parentheses and say 5x squared plus x, and then finish the parentheses, and then divide that by the x squared. And then we always have to finish with x, and hit enter, and there's our answer. Now look at one of the issues, right? This answer is not written in exact form, and most of the work that you're going to have to do is going to have to be written in exact form. So if you're relying on your calculator, you got to just double check that this value is equivalent to 5e minus 4. And I'll check that really quick. So let's do 5 to the power of e, or excuse me, 5e to the first power. I think I said minus 4. Yeah. And notice those values are exactly the same. So equivalent expressions, that is a skill that you should definitely be used to. We're going to do this a lot more as we go along. Okay. Now, I don't want to spend a ton of time on this. That's why I didn't have you do these ones as warm-ups, but I want to show you this really quick, just so we're not even going to do this all the way. Maybe we'll do this one on our calculator, but what I want to show you is if I ask you to do this one by hand, remember, who's your best friend? Right? Algebra, the same way it was up here. We were able to divide each piece by an r squared to make it a simpler integral. Well, here I've got a binomial times a binomial. And what's probably going to be a whole lot friendlier for you is if you FOIL this out. Right? So x times x is x squared. And then I'm going to have an x times 3, so that'll give me a positive 3x. And then I'll have a negative 1 times x. But when I push those together, that's 2x. And then the end part, negative 1 times 3 is negative 3. And now you can take the antiderivative of each one of these very quickly. All right, why don't you try this on your calculator right now? Let's do that one just so you get another practice of how to do this in your calculator. Again, you can type in either option. Ooh, that's not cool. Okay, you can type in the original one, or you can type in the algebra equivalent, and you should get the same answer either way. So I'm going to go to math. You can just hit option 9, negative 2 to 3. And then I'm going to type in the original one, because if you choose to do that, you have to be careful with your parentheses. And then we always end with dx. Now, regardless of whatever variable it is, we always use the variable x when plugging into our calculator. And you can see very quickly that you get your answer. You might even be able to turn this one back into a fraction and get 5/3. So you should get the same answer if you do that by hand. Okay. Now, I share this with warning, right? Because I don't want students to only rely on this calculator and forget about how to do these by hand. Because that is definitely something that they test on the AP Calculus exam. You're going to have to do some form of an integral by hand. All right? Okay, so really quick, I just want to talk about next trimester, actually the end of this trimester, and then next trimester. So let me show you our calendar right now where we're at. Today, it is the 8th. We are doing section 6.4. And this isn't 100% exact. Our homework tonight is actually a delta math. I just want to give you a quick breakdown. So on Wednesday, we have a review video you're going to watch. And then we've got our review in class on Thursday. After that, we're going to assign a test. And the Chapter 6 test is due on Monday, which you don't have school on that day. So you could do it Thursday night, or you could do it anytime up until Monday at like 9 p.m. All right, so that'll finish this longer Unit 6 that we're headed into. By the way, all of your missing homework for this unit, including the 2 quizzes that we just had, needs to be due by Wednesday. Okay, this week, Wednesday, you got to get that working. And some of us, a lot of us, have a ton of missing work. Okay, so please make sure you're working on that and getting that in and submitted before the test. I'll even accept it if you turn it in like Thursday. I'll accept that as well. But we just need you to get that work in. Okay, so we're going to take a test that is a summative test. And then what do we have for the rest of the school day, or school, I should say, second trimester? Well, we were going to do a mini unit on section 6, unit 6, part 2. We're going to cover something called indefinite integrals, which is very similar to what we've been doing, but it has some harder or more challenging integration with something called U substitution. So that's what this week is. We don't have school on Monday. So we're going to do section 6.5 and spend 2 days on that. And I actually think we may spend another day on 6.5 here. It depends on how the first 2 days go. And then we're going to do something called long division and completing the square with integrals, which isn't horrible. It's just a little tricky. But there is a small change to our schedule. The last days of this trimester for you guys is March 1st and 2nd. The 3rd and 4th have actually changed into no school days for you. So you actually get a couple more days of your spring break because that's going to be teacher prep time for 3rd trimester because we're now going back to hybrid after 3rd trimester. Or excuse me, after spring break at the start of 3rd trimester. So I'd like to just share with you as well. I will be actually in school. I will be no longer teaching from home for those days. And the reason is by then, hopefully my daughter will come and I don't have to worry about my wife being pregnant and potentially getting COVID. And we didn't know what that would be like with having having my wife being pregnant. But we've talked to the doctor and they did say that infants are not at any super high risk of catching COVID. And I figure if I'm in person with you all 3rd trimester, I can take the proper precautions and still meet you guys in the classroom, but also still provide a safe environment for my family at home. So anyways, you may have heard that there is a little bit of a shift in this 2nd trimester here. Next week, this Tuesday is going to be hours 2, 4, and 6. So you guys will be Tuesday, Friday. And then the 22nd and 23rd is going to be hours 1, 3, and 5. So there was some shift in this week, and there's actually a little bit of a shift here in the end of the 1st is going to be hours 1, 3, and 5. So there is some shift as we get to the end of the year, and we had to do that so the days actually balanced out, equal days of hours 2, 4, 6, and 1, 3, 5. Anyways, I just wanted you to be aware of what was coming up for the end of this trimester, and then starting 3rd trimester, we are going to be in a hybrid model. And there is some shift as well on that. You probably got some information. If not, we're going to be going over that a little bit more detail next week. So you might have heard about the schedule coming up. Anyways, if you got questions about it, we could talk about it. I just want to make sure we get through everything that we have here. All right. We are going to, if it comes up, we're going to continue to talk about the properties of integrals. Some of them we can acknowledge but not write all the time, and that's what I mean by if it comes up. We're going to introduce a newer concept called average value, and then we're going to interpret integrals using motion. So wrapping up kind of the last new material for this unit today. All right, we're going to actually jump right into this average value piece. So what I'd like you to do, oh, I forgot to erase all this. Let's look at, keep this stuff right here. And here's what I'd like you to do. We're going to talk about the average value, which is really just the mean value theorem for integrals. So if you remember what the mean value theorem was, right? That was if a function was continuous and differentiable on an open and closed interval, then there was a value where the average rate of change was equal to the derivative. Well, since we're talking about integrals now, and integrals is the area underneath the curve, let's think of this visually right now. So I'd like you to draw this picture. You do not have to draw this one right here. This is just a little side note. But I want you to draw this picture just so we can get a visual understanding of what we have going on here. Okay. So what we're going to talk about here is think about, we hinted at this with the properties of integrals at the start. We said, well, what if we took the lowest spot on f of x? So here's the lowest spot of the function. And then I drew a line straight across at that minimum. Okay. Now, if I just drew a line straight across here, we could find the area under this curve, no problem. It's a rectangle, right? I take the minimum height times the difference between A and B, and that would give me the total area under this minimum line. But we could do the same thing with the maximum as well, right? I could find the maximum spot, and then I could find the area underneath that curve. Well, the minimum is definitely an underestimation, and the maximum is definitely an overestimation. So what if I actually found the average? Somewhere between the max and the min is the average value of the area. So where would that average value occur? And that's the part we're going to think about. Right here, this point on the function, a lot of times we just call it C, but that C value is actually the spot at which the average value is exactly the max plus the min divided by 2. So remember, when we find average of something, we add them together and divide by 2. Well, we're basically going to do that, except for instead of dividing by 2 here, we're going to divide by the difference of the x values. Okay, this is just another view. You can see that if I drew the lower spot and the upper spot, there'd be an underestimate and an overestimate, and then halfway between, roughly, would be our mean value or the average value. Okay. Now, I don't think you need to write all of this. I'm going to actually highlight what I want you to write. But let's just read officially what is the definition of the average value. It says, suppose f is a function that is continuous on the closed interval, and that's what we drew here, a continuous function from a to b. The average value, which a lot of times they put y bar, of f over a to b is given by this spot right here. So this is the part I would like you to write in this box. And actually, we call it AV, so average value, and then this lower subscript f just refers to the function. So a lot of times you see us refer to this as AV. I don't really see y bar a lot as a notation. I'm not 100% sure, but that might be specific to this book. It may be a common notation. I just haven't seen it a lot. But average value, all it is the area under the curve. Notice the second part here is just the area under the curve. And then what are we doing? We're dividing by the difference between A and B. So we're dividing by the upper bound minus the lower bound. And that will give us the average value or the average area underneath that curve. And one way to think of this is your b, I'll do this later once you guys finish writing it. Okay. One way to think of this is your average value is kind of like the height of your middle value. And this b minus a, that's really like the width. You're dividing by the width of this rectangle. And then we know that the top part, the area under the curve from A to B, that's your full area. So technically, all we're doing is take the area divided by the width, and that will give me the height. That basically tells me how tall is this average value, or what is the output right here? What's the F value at this random point C? Okay, so we'll show you how to do it. The nice thing is the only difference in this problem is from what we've done before is this new part right here. You're still doing the area under the curve, which we found sometimes we can use our calculator for this part, and then all we have to do is multiply by 1 over b minus a, or some people just say divide by the upper bound minus the lower bound. And that's all average value is. Okay, let's look at an example or two to kind of give you guys a good frame of reference for how and why this works. And we should be able to even check this graphically. So we'll do this one together, but I'm going to give you a minute just to get this part copied. And we're going to do this by hand, no calculator, because this definitely would be a no calculator problem. When you're doing a problem like this, a lot of times, a lot of students end up going very fast and they skip over that phrase, average value, because that's what tells me I need to take the area underneath the curve, so the average value is just the area under the curve from your lower to your upper bound, and you just want to make sure that your lower bound is always here, your upper bound is here. If for some reason they wrote it the other way around, we could flip those bounds and make it negative. That was one of the properties we talked about. Now, notice this part that I had written here is just the area under the curve from -1 to 2. So the average value part, this phrase, tells me all I have to do now is multiply that by the upper bound minus the lower bound. So 2 minus -1. And then the rest is just, we know that as a multiplier, this becomes 1 over 3, right? Because that ends up being 3. So now all I have to do is evaluate the antiderivative just like I did before. So I'm going to go ahead and add 1 to the exponent because we're undoing the power rule. So if I put a 4 up there, remember I have to multiply by 1/4. But notice that 1/2, I didn't really do anything with that yet. So I'm just going to think of that 1/2 as a multiplier. Now we could have, by the way, this 1/2 is a multiplier, so I could write the 1/2 out here and do it as 1/6, and then deal with the green part. Or, since I know these are fractions, those are going to combine together anyways. But there's the antiderivative. If you're not sure on that, you could take the derivative of this and you would get back to where we started. But then I have to evaluate from 2 to -1, just like we did in the warm-up. So I'm going to leave this 1/3 for the end. We'll deal with that in a little bit. And I know that 1/2 times 1/4 is 1/8. And then I need to evaluate this value at 2 and at -1. Now, I should be careful. I've preached this. Right now, this is not correct notation. And I'm curious if you know why. If I stopped right here, this answer would be wrong. Okay? You might be thinking it's 1/3 times this entire thing. So officially, this 1/3 is multiplied by all of that. And that's something, notice how small that parentheses look, but that's a big deal in the overall process of how we do our answer, that if you miss a parenthesis like that, you're not going to get full credit on the AP test. You would actually lose a point because this answer would not be correct. So now let's simplify. I know 2 to the 4th power. See, 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is 1/8 times 16, or 16 over 8, which is 2. -1 to the 4th power is +1 times 1/8. So I'll have 2 from this part minus 1/8 from this part. And then that answer is going to have to be multiplied by 1/3. Well, since we're not using our calculator and I want to get these combined together, technically, by the way, you could have stopped right here. If this was an AP test, you could have stopped right here and not done any simplification, and you would have gotten full credit. Okay? They never test you on your algebra skills, they test you on the calculus skills. So once you get to a spot here, I'll tell you to stop. But since we're practicing this, we want to go all the way through and just see if we can get to the final spot. So what do I need to do? I need to make this denominator an 8. So I'm going to times by 8 top and bottom, which is 16/8, which I could have just left as is here. So then I get 1/3 times 15/8, right? 16 minus 1. And then what I would do is I'd say, you know what? This 3 and this 15 are going to reduce out by a common multiple or a common factor. So that'll give me a 5 on top and an 8 on bottom. And there is the average value of the function f of x from this interval. Okay. Now, we do want to also make note that a lot of times students see this question and they get it confused. Okay. So what if I ask you to find the average value, that's the average area under the curve. Okay. So you're doing the integral, and then you're basically multiplying by 1 over b minus a. If I ask you to find the average rate of change, that goes back to Algebra 1. Right? What is another word for average rate of change? That's your change in your y's over your change in your x's. This is the slope between f of -1 and f of 2. It's the slope between those points. Okay. I'm going to show you a graph here in a second once we get done with this, but What do I need to find slope? Well, slope, or average rate of change, is your outputs, f of 2 minus f of 1, over your inputs. Oops, I don't need to use b minus a, because we know what a and b are. So it's 2 minus -1. But notice, all that is just your slope. And you don't need to show the work, but if you plug 2 in here, maybe you want to, but I would need to figure out what is f of 2. Well, 2 to the third power is 8. 8 times 1/2 is 4. So there's f of 2. And then we got to figure out what f of -1 is. And -1 to the third power is -1. We get the output as -1/2. And on the bottom, 2 minus -1 is 3. So then we just have to simplify that, and we'll actually get our slope answer. However you want to simplify this, I might call this 8 over 2, and then subtract the negative would be plus 1/2. So I would get 9/2 divided by 3, but I don't like dividing by 3. Oops. Instead of the divide by 3, we're going to times by the reciprocal, and then you'll get a 3 canceling out on top and on bottom. So your average rate of change, or AROC, is 3/2. So notice that's not the same as the average value. All right, let me show you just quick visually what did we do, so you can kind of see the difference on a function. You don't have to write this part. Let's see if I can sneak it in over here. Okay, this part, the average rate of change. Well, what did we just do with that? We just said, what if we took the two endpoints, -1. By the way, this green or this red graph is the graph of the original function f. So the average value, if you remember, is the slope of the secant line. That's what we found right here. And this slope would be up 3 over 2, roughly. So there's your average rate of change. And then what is the average value? Now, the average value tells us the average output. If I found the area underneath the curve, now this is the part where we got to visualize it, right? The area underneath the curve for the first part would be negative, and then it would be positive up here. So where is this average value going to occur? At 5/8. So what is 5/8? That's like 0.625. So if I went up about 0.625, that might be about right here. And if I found the average value between these, it would roughly be this rectangle here. That area under the curve would be the average value of all that. So please know the difference between the words average rate of change and average value, because that is definitely something they try to trick you on. Okay. All these notes will be posted, so if we went over something too fast or you want to go back and look at it, you definitely can. I want to show you a couple of problems that you're going to be doing tonight. And I don't want to spend the time going over all these in terms of having you guys write it down. So let's just look at it quick. And like we talked about, reading the directions is very important. So the regions A, B, and C in the figure below are bounded in the graph of the function in the f and the x-axis. The area of region A is 4. The area of region B is 19. Now notice, even though they tell us that A is 4, they don't tell us that it's negative, because it's just how much space does it occupy. We know it's negative because it's below the x-axis. B is 19 and C is 21. So what are they asking for? What is the average value of f from -7 to 8? All right, so I want to go from -7 to 8, which means I have to add up the area of those. So it's a really quick, this is just a, do you understand what the average value means? Okay, so we're going to go from -7 to 8 of the function f of x. Now that part alone is just adding these areas up. A was -4, B was +19, C is 21, so we're just going to add those up. But the average value says we're taking the difference of 8 minus -7. And remember, that's just the average value is just the area under the curve multiplied by 1 over b minus a. So then we can show our work for this. If I just focused on the area under the curve, we could, by the way, you could use your integral properties and rewrite this as the area under the curve from -7 to -4. But we know that answer already. You know it from -4 to 1 is 19. And then we know from 1 to 8 is 21. So we don't have to use the properties of integrals. And then I've got 8 minus -7, which is 15. And notice they say write your answer in simplest form. That means don't use a decimal, right? You want to take and write it out as a simple fraction. So what do I have? I have this whole piece is equal to 36. So 36 times 1 over 15. And then I can just divide those by 3. Right, so that's the simplest form piece. Sometimes students write that and they forget that they're supposed to simplify. So my final answer would be 12/5. And that's the average value. Okay, so nothing quick. It combines what we already know with just the new concept today is just right here, the blue part. Okay, let's look at another one, because as we found, they like to ask you questions in multiple different ways. So below, this is the graph of f. Again, don't write this, but it says, which statement about f is true on the interval from -9 to 9? So what we want to do is we want to say, okay, well, the average value is negative, and the average rate of change is positive. Now look at all the way down, they're asking us to compare the average value to the average rate of change. Well, let's start with this really quick. Average rate of change. The average rate of change is the slope between -9 and 9. So right there, if you drew that line in, you automatically know something about that. So here, your, oh, come on. Hold on one second. Let's try this. Your average rate of change is slope. And we don't need to calculate it. You could calculate it if you want, but we just need to know, is it positive or negative? Well, this is a decreasing slope. So that's negative. So right away, I know it can't be this one because the average rate of change is now positive. Same thing here. So that's a 50-50 shot now. So now we have to think of, okay, what about the average value? Well, the average value is going to be 1 over, and then we're doing the upper bound minus the lower bound. So we're doing B minus A. So if I do that portion, notice that's automatically going to be a positive number. There's the average value. So I know that we get positive 18 on the bottom here, which means my sign value, positive or negative, is going to come from what do we have to kind of estimate here about the area under the curve? This part right here, is that positive or negative? Well, let's look. And all we can do is kind of estimate here, but if I look at the area underneath the curve, we know that's positive. We know this is positive. And then I know the area here is negative. And that's negative. So just by looking at this, I have more negative area than I do positive. So my conclusion is that this region right here is going to be negative because there's more red area below the x-axis than above. And timesing it by 1/18 doesn't change the sign value. So the average value is negative and the average rate of change is negative. Okay. The really quick problem, you don't need to show any work for this. You can look at it and just make that connection. All right, I do want you to write this one because this is a connection for our properties of integrals as well. I'll give you a second to write this down. So we have to find the average value given this piecewise function. I'm a big fan of just kind of writing out what they want me to find. So I know when I see the words average value, I'm going to have the difference of 1 over b minus a. Well, in this case, a is always going to be the smaller number unless they write it differently. But we want to pick the difference of b minus a. So there's the average portion. And then it's just the integral from -2 to 1 of f of x dx. So that's what we're trying to find. However, we have a small problem here. Now we could graph this if we wanted to, but we know that this area is split up at anything less than -1 and anything greater than -1. So we actually have to use our properties of integrals here to help set this up. Okay, so I'm going to deal with this part first. Subtraction of a negative is a positive, so that's 1/3. And then the piece that I want to do is I want to split up this integral. I'm going to take the area under the curve from -2 to -1. Because of the domain. And then because of that reason, I have to use f of x as -6x minus 3. So now, most likely that portion of f of x will be written in parentheses. But we know that we need to get the full area under the curve from -2 to 1, not -2 to -1. So I'm going to rewrite another integral that starts at -1 and goes all the way to the end, which is 1. And we know that anything greater than -1 has a different function. Okay. Now, I have confidence that if you were able to get to right here, you could evaluate each one of these all the way, taking the antiderivatives, evaluating the upper lower bound. But I want to save a little bit of time. So we're going to do this in our calculator. Let's do that portion and get our answer. And then let's do this portion as well. And then we know that we're adding these two answers together because that's the area under the curve for the whole piece. But then that's not our final answer, right? The average value would be 1/3 of that. So go ahead and do that portion in your calculator. I should be able to do mine here as well. Ooh, I'm glad we're doing this one. When you look at the answer to your second integral, all right, so when we look at this first piece here, from -2 to 1, we get an answer of 6. And then the next one, this one, remember what that means. That's scientific notation, which means I would need to move the decimal spot 13 spots over here. So basically, that's 0. And then nothing crazy now. 6 plus 0 is 6. 6 times 1/3 tells me the average value is equal to 2. Okay. All right, so we got one last concept. I remember I threw this example in here just so you guys could see it. But the intent is I don't want you to write this down. This is a problem that kind of gets kids, they get stuck or they freeze on a problem like this. So I just want to show it to you quick. This would be a free response style question. It says the rate of fuel consumption in gallon. Now notice right away they say rate, right? So you have to have some type of rate in your units. So the rate of fuel consumption is in gallons per minute, recorded during an airplane flight which is twice differentiable. Remember that twice differentiable just means the derivative exists twice. And since it's differentiable, that implies it's continuous. So we know it's continuous, and we know it's strictly increasing. That's also important. This function is always increasing over time. R is given in the table and the graph, and then it gives us select values of R, which is the rate of fuel consumption. So R means rate in this case, from 0 to 90. So look at the first question. Actually, I'll show you the table. So here's the table, and here's the graph of R. Now, both of those, these are equivalent. So it says from 0 to 90, explain the meaning of this. And what does this mean? Now, a lot of students say it's the area under the curve, and they stop. Well, wait a minute, there's context here. We have to think about, okay, if this is a rate, we know that this is the rate, and it's measured in gallons per minute. Now, we know that a rate is like the derivative, and we know an integral and a derivative reduce each other out. So this integral is going to actually reduce out the rate, and I'll show you the way that they would grade this. Okay, if I undo the rate, that's going to get rid of the gallons per minute, and it's going to leave us with just gallons. So what this is this is the total accumulation of fuel from time 0 to B in gallons. So you got 1 point if you said the meaning of this, which is the total amount of fuel in gallons consumed for the first B minutes. Now notice, -1, so you actually didn't earn any points if you didn't make a reference to how long that's been going. We know that we're going to start at 0 minutes to B minutes. So just keep that in mind. Now look at what number 2 is asking. Number 2 says, explain the meaning of this. Right? We know what we just found up here. This is the fuel consumption, but what is 1 over B? That is your average rate of change or average value. And remember, these are minutes, right? So I'm dividing by minutes again. So that means the answer down here is you got 1 point if you correctly said this meaning. Well, what is it? 1 times B from the integral from 0 to B is the average value of the rate of fuel consumed in gallons per minute. So you're basically just telling the person what that is. It's your average value of fuel consumption. Now this is gallons per minute because we're putting back in the average value. We're dividing by B minutes here. So that's why the gallons in the first one turned into gallons per minute because of the divide by B. So anyways, that's just a quick reference. We will see those come up as we learn more and more. All right, I don't want you to write this. I know I say that a lot, but on the next example, we're going to fill all this stuff in. So I just want to look at how do we interpret motion with integrals, and specifically particle motion. If a particle is moving left to right or up and down, what do we have? We have 2 different things, okay? And we kind of hinted at this a while back, but it's been a long time. For an object in rectile linear motion with velocity, okay? So this is our rate. Velocity is a rate, miles per hour, feet per minute. The net displacement, so the total change in position, is given by the regular integral. So that's like your area under the curve. So that's just like your total feet that you traveled or total miles that you traveled. Okay? So net displacement is just your average rate of change. Well, what is total distance traveled? Total distance traveled is almost the same thing. Notice it looks like almost the same thing. The only difference is look at the absolute value bars. It turns all distance positive, and it adds up just all the distance as if it was positive, which is really like the integral of the speed, because speed is always positive, but that's what represents total distance. So let me give you a quick visual, and again, you don't have to write this slide, because the next slide we're going to basically redefine this. So let me show you what we have here. Let's say that this is a graph of velocity, and I told you to find the net placement between A and B of the velocity. Well, all that is the area under the curve, right? It's the 5 up here plus it's the fact that this is negative. Now they don't tell us it's negative, but we have to know it's below the x-axis. And then let's say that I was going feet per minute here. So velocity is feet per minute. So that means I went 5 feet and then I went back 9 feet. So I went 5 feet to the right and back 9 feet to the left. What's my ending position or my total displacement? It's -4 feet. That's where I would be at the end of A to B seconds. Now, what if I asked you to find the total distance of this? All you would do is you would do the exact same thing, except for now you're taking the absolute value of the velocity, which is just all of these values are positive, right? So the 5 stays positive, and the 9 turns into a positive. And what does that mean? Total distance. Well, if I traveled 5 feet to the right and 9 feet to the left, how far did I walk total? I walked a total of 14 feet. So that's the difference between net displacement and total distance. Now, in a couple of units, Unit 8, they're going to give us a starting position. So let's say I started 10 feet away, then I would take my ending position plus 10, and that would tell me where I started or stopped. All right, this is the one I want to write down, and we have just enough time. This is our last example today. So let's do this in a couple of pieces. We have an object in rectile linear motion, which when you see that, that's just a fancy way of saying it's moving left or right or up and down. In this case, it's moving along a horizontal line. So it's moving left to right, and here's the velocity equation in meters per minute. So we know our units, right? We know we're traveling, distance is meters, time is in minutes, and then they tell us on what interval do we want to travel from 0 to 6. So part A says find the net displacement of the object from 0 to 6 and interpret the results in the context of this problem. So what a lot of students end up doing is they read way too fast and they see that word net displacement, or they skip over that. So your net displacement is basically adding up all of the positive and all of the negative area, and we're just finding our regular area underneath the curve. Now instead of VT, we know what VT is equal to. And if we were to graph this, this might, I don't know without graphing it, but it might have some of the area that goes above and some below between 0 and 6. And actually, maybe I will create a graph so you can kind of visually see what this looks like. I'll just pull it up on Desmos as you guys write the rest of this down. All right, you don't need this graph, but you can definitely tell that we've got area that's above the x-axis between 0 and 6. And then you've got area below between 1 and 5. And you just have to find that area. Now, we don't have a ton of time left, so I'm just going to do this part in my calculator. Right? I'm going to evaluate the integral in my calculator just so we can get the answer. I am making the assumption that you could do this by hand because the AP exam would definitely expect that you would be able to do that by hand. Okay, I did this really quick, but the displacement is negative 18. Now, what does that mean in the context of this problem? Well, displacement is your ending position or your total distance traveled. So this would be negative 18 feet from wherever we started. Right? So basically, I'm negative 18 feet from where we started. A better way to describe that would be now watch how I write this. We are 18 feet to the left of where we started. And this is a better way to describe it because I didn't put negative 18. The reason why I said 18 was the left refers to being further to the left than the right. Okay, because the blue area would be we would be travel to the right, and then at 1 I would change positions from going to the right to the left, and then I'd be going to the left a long ways, and then at 5 I'd come back towards for 1 second or 1 minute. I'd come back towards, but at the end, after all of it, I would be 18 feet to the left of wherever we started. And that's what net displacement is all about. All right, last one, really quick. We're going to do this in our calculator as well. This one says find the total distance traveled from 0 to 6. And this one I have to show you how to do absolute value in your calculator. So please make sure you pay attention to this. It's the same thing, except for now we're going to throw absolute value expressions around that velocity equation. I'm going to go from 0 to 6. The absolute value. And then the only question is, where do we get the absolute value bars in our calculator? All right, now there's more than one way to do this, but I first have to start the integral. So I'm going to put math, option 9, from 0 to 6. And then I need the absolute value, and there's two ways to do it. Some people like to go second catalog, and notice it's the very first option. So I'll just hit enter. So that again was second catalog, the 0 button. Or if you don't like that, some students just hit the math button, and if you press over to number, so math and then over, there's the absolute value as well. So you can find it two different ways. I don't care how you do it, but you do need those absolute value bars around your entire function. So now I'm going to type in 3x squared minus 18x plus 15. And then we just have to end with dx. And there we go. Notice that even if I round this to 3 decimal spots, it's still going to be 46. If we did this by hand, our answer would just be 46, which is completely fine. But what does that mean in the context of this problem? Well, the total distance traveled from 0 minutes to 6 minutes, or you could say in the first 6 minutes, because that's the same thing, is 46 feet. So what that did was it took any area here and it made it all positive and it just added it up. Okay. So really sloppy handwriting. I apologize. I was trying to do it fast. The total distance traveled from time 0 to 6 is 46 feet. Ooh, not feet, meters. Curious how the AP problem would approach that. If you accidentally put the wrong units, if they would give you credit for that. I don't think they would. I think they would have taken off points because I put the wrong length in there. All right, so that's it. Net displacement is just your regular area under the curve. Values are positive, negative, whatever they are. You just add them up. Total distance takes all the values and makes them positive. All right, your homework tonight. Really quick, make sure you understand this. Homework tonight is 6-4 day 2. On Wednesday, you're going to watch an Edpuzzle video, and then you can start the review. If you want, you could start the review today. It's a worksheet. It'll help you for the test on Thursday, Friday. The test will be assigned on Thursday, Friday, but is not due until Monday, the 15th. I'll be available in my office hours if you have any questions. Have a great day.